Hey folks, all right, here is review for the test on Friday. Again, this is going to be in 15-minute increments, so this will definitely be in two parts. Um, my review is definitely spaced out more than your review because I need more room to write since I'm writing on the smartboard. So go through this and fast forward if you need to. All right, again, if I read the directions, just so you know, it says solve for x. And if you can factor, you're expected to do so. And remember to try V1 first, and don't forget that your graph might bounce. So those are all things I want to keep in mind as I go through and do this. So number one, the first thing, if I can factor, I'm going to. They don't give me any clues, so factoring will definitely be the fastest way. So when I look at number one, I notice a pattern possibly between my first set of parentheses and my second set of parentheses. You know, 2 and 5, 4 and 10 seem to be pretty similar. One's just doubled the other. So I'm going to try to factor. In my first set of parentheses, I'm going to take out a 2x squared. And when I take the 2x squared out, I'm sorry, back up. I'm not taking out 2x squared. I'm taking out x squared. And when I take that out, I'm left with 2x minus 5. And then when I go to my second set of parentheses, I notice that I can get 2x minus 5 out of that. And I'm going to take a negative 2 to do that. So when I go and ask myself, is this factorable? My answer is yes. Since it's factorable, I'm not going to bother with any of the P over Q list. Instead, I'm just going to go straight to my complete list of factors. So I get x squared minus 2 as one, and I get 2x minus 5 with the other. And at this point, I assume you guys are good about setting these parentheses equal to 0 and doing that math. So I'm not going to show you how I get these. On the x squared minus 2, I would add 2 and then take the square root of 2, which is going to be 1.4 and negative 1.4. And with the 2x minus 5, when I set that equal to 0, I'm going to get 2.5. My y-intercept, going back to my original equation, is 10. And now I'm going to graph it. So you can see, I do give you a graph, if you look right here, but I do expect you guys to graph it. So on my graph, I'm ready to graph now. I'm going to have on the positive side 1.4. I'm going to have 2.5. I do expect you to label these points on the graph on the assessment. On the negative side, I have negative 1.4 and again a y-intercept of 10. Since it is a third power, that's going to give me a line. It's a positive slope line. That means it's going up here and down on the left. None of my points repeat on my x-intercept, so it's going through all the points. I just have to turn to get to the next point. And there you go. There's number one, factorable. Great. All right, let's go to number two. So again, what I'm going to try to do is hopefully it's factorable. But when I look at this one, I really don't see a pattern between my first set of parentheses with the 2 and 5 and then the second set of parentheses. So number two is not going to be factorable. And if they gave me a clue, that would be great. But you know what? They don't give me a clue. So what I'm going to do is cheat. I would technically put this into the graphing calculator. And I've already done that step for you. And when I go to the graphing calculator, I want to look for a point that is noticeable. And this one's kind of tough. So what I notice is I think this one definitely looks like negative 1. So I can cheat with that one. And then maybe this one here looks like 2. So, but I'm more positive about the negative 1. So filling in my blanks, is it factorable? No. Technically, I'm supposed to come up with my P over Q list. P is 6. Q is 2. So if I did my factors of 6, that would be 1, 2, 3, and 6. My factors of 2, 1 and 2. And now I should make a list of all of my factors of 6, and they should go over all of my factors of 2. So doing that, when I take all of my factors of 6 and put them over 1, that's just, 1, 2, 3, 6. And then when I take all those factors and put them over 2, 1/2 is new. 2 over 2 is 1. 3 over 2, that's new. But then when I take 6 over 2, that's 3. I already have that listed, so I'm not going to list it again. And just a reminder, even though in my P over Q list I have a total of 6 numbers written down, there's really 12 of them because it's positive and negative of that whole list. It wasn't factorable, so now I'm going to cheat with -1 because I'm more sure about -1 than I am about 2. And since I am cheating with -1, I should get 0 at the end. So going through this, here's my list. I'm going to be quiet for a little bit and just go through and do the math. And there's my 0. So I'm going to put x's with it. And now what I want to do is factor this. And so with this method, I'm going to be using the x. So again, not a lot of room. I'm going up top. Here we go. A times c is 12. B is here. So when I go for my side numbers, it's going to be -4 and -3. Now that I want to factor, I am going to erase my box because I don't need these numbers. I'm going to use the old way, which said put -4 and -3. And remember, I'm not just going to put x here, I'm going to put 2x here. And in the first set of parentheses, I can take a 2 out, so x minus 2 is one of my final factored parentheses. The 2x minus 3 I can't do anything with. So when I go to my list of final factored parentheses, I will be putting in the x minus 2. That will give me 2 as an x-intercept, so I could have cheated with that one. It did work. I'm also going to put the 2x minus 3 in there. When I set this equal to 0, I get 1.5, which is the one I couldn't quite tell about. And then I have to remember, I did cheat with -1, so I'm adding that into my list of x-intercepts. And x plus 1 would have given me that. Now, if I had cheated with 2 from the beginning, then my final numbers under the synthetic division, had I factored those, I would have gotten the 2x minus 3 and the x plus 1. So remember, you need all your parentheses and all of your x-intercepts. The y-intercept is 6, and now I'm going to go up and graph. Even though I gave you a graph, you are still expected to graph. So I've got -1, I've got 6, 1.5, and 2. And it's a third power that's going to make it a line. It's going up on the right and down on the left. And now I'm just going to connect. Nothing is bouncing. It's going through all the points. And there you go. There's number 2. Not factorable, but we were able to figure out the clue. All right, let's go to number 3. So number 3, is this factorable? Well, let's take a look. I'm going to group them because with 4 terms, I would definitely try grouping. And it's not looking like it is factorable. I don't see a pattern between my first set of parentheses and the other one, so I'm not even going to bother. And instead, I would answer my question, is this factorable? No. So what I technically am supposed to do, again, is take my factors of p. In this problem, p is 12, or rather -12, and q is 1. And if I take my factors of 12, remember, you've got your factor program, you've got your golden page from your notebook, my factors of 1, and I'm going to take all the factors of 12 and put them over all the factors of 1, which in the end it just will be the factors of 12. You are expected to complete this list on the test. You won't have to do it for all the problems, but if I don't give you the clue, you fill in the list. Um, Then I would graph it. Again, I already gave you guys the graphs. So this one looks like 3. This one looks like -1. And this one looks like -4. And I'm pretty sure about all of them. So I'm just going to test with 3. I'll use the positive one. So I'm going to do that here. So I'm going to put 1, my numbers in. Now remember, you could have tested with the other ones. Realize that if you test with something else, your work's going to look different. So but I can't do all the versions. There isn't time. So here I'm going through my synthetic division. Oh, back up. That's not 8. Sorry, 15. All right, again, I'm going to put some X's in here, and when I do that, I'm switching to blue. Um, I get x squared plus 5x plus 4. And this is what I'm hoping is factorable. I do not need the synthetic division box anymore. I'm going to erase this for lack of room. And I'm going to go to the factoring. So a times c, because there's three things. So a times c is 4, b is here, side numbers are 1 and 4. And again, because it's just an x squared, this is simple parentheses. X plus 1, x plus 4. And now I could put those in my list of complete factors. I and then I get negative 1, which was one of the x's. I just didn't choose to cheat with that one. Negative 4. But what I do need to remember is that I cheated with 3, and my parentheses that would get me there is x minus 3. Again, all the parentheses, all the x-intercepts, including the ones that you cheat with. My y-intercept is negative 12. And even though it is graphed for you, you are still expected to graph. So here's negative 4, negative 1, here's negative 12, and 3. And now I'm going to make my u. Here we go. No bouncing, it's a line. And I think I just said it's a u, it's a line. And it's going through all the points, no bouncing. So here we go. All right, there you go. There is number 3. Let's start number 4. I might run out of time, so number 4 might pick up on the next segment. So first of all, looking at number 4, it definitely is not factorable because there's 5 terms. So is it factorable? No. Will I have to come up with my p over q? Absolutely. 10 is, or negative 10 is my p, 2 is my q. So over here, my factors of, and I'm just going to write 10, are 1, 2, 5, and 10. My factors of 2 are 1 and 2. So when I make my list, first I'm going to take all the factors of 10 and put them over 1. And now I'm going to take all my factors and put them over 2. So I add a half. 2 over 2 I already have. That's 1. 5 over 2 I don't have. And then 10 over 2 I already have with 5. So again, 6 numbers listed, but there's actually 12 numbers there because of the positive and the negative version. All right, then I would put it in the calculator. Again, I did that. What are the ones I'm absolutely sure about? That looks like negative 1. That looks like 1. And let's see, I'm going to stretch and I'm going to take a guess and think maybe this one right here is 2. Now on this one, when I have to choose between those 3, you want to choose the odd man out. 1 and negative 1 will cause more work later. Chances are we won't, when we're done with our synthetic division, what we get won't be factorable. So choose 2. It will be less work for you. So here I go. I'm going to get through my synthetic division on this one, and then I'll have to pick up on the next segment. So here we go. So going through really fast. And now I'm going to put some x's in there. Here's my remainder, constant, x, x squared, x cubed. And then this is what I'm going to try and factor. So what I'm going to do is stop with number 4, and you're going to have to pick up on the next version to see the factoring and the rest of the graphing of this problem.